The electrospinning technique is actually by creating an electric field between the plate where we are catching the fibers and the needle where the material which is dissolved is actually coming out. At the moment that it's coming out of the needle, the solvent is actually evaporating and the fiber itself, which is in a diameter something between 1 and 2 micrometer, will electrospin on the bed. So we will actually tune the speed. We will be able to tune the distance between the collector and the needle. We can also tune, for example, this arm, where we can say if it's static, that we're actually spinning on one surface, or that we can let it move, so that it's actually spinning over an entire large surface. Now, another parameter which we can work on is the voltage. Depending on how strong the electric field is, we can actually make thicker or thinner fibers or thicker beds. I can show you how it looks like afterwards. That's only a small, after 5 minutes, we will actually have what it looks like. The idea is actually that next to regular electrospinning, we would be able to use co-extrusion electrospinning, where we have a needle inside another needle. Then we create sort of a core and a shell, where two different layers are electrospun at the same time. And when you do that, you have the possibility to incorporate, for example, the odor-absorbing material inside the shell and the color indication, which will indicate if there is an infection or not, inside the core. And at the same time, we can create a fiber bed. Of course, it will take a small while before we have a complete bed. But when we have the beds, we would be able to have a dressing which has all the properties we would need. Additionally, what we can also do is, which is also part of the DERMA project, is create the antibacterial compound. Either we can incorporate it in one of the needles, or we can also incorporate it by soaking the dressing inside, for example, a solution of polyvinylpyridine iodine, because iodine is used a lot for antibacterial properties, or other compounds which are also being tested here at the lab. 3D printing itself is a technique which we can use to actually make scaffolds or other structures which could be useful in the wound dressing story. Why? For example, if we would 3D print some materials which are, for example, the natural-based or the synthetic-based materials, we can incorporate them with the odor-absorbing or color indication which we will need in the DERMA project. And in this case, what you will see is that actually some scaffolds are being printed, but other models or tubes have already been printed to prove that actually the accuracy of the structure is very, very narrow. We think that 3D printing is more of a next step. If we can fine-tune the electrospinning, then we can actually go to a combination of 3D printing and electrospinning. That's the technique which is standing over there. The idea here is actually that we can combine 3D printing and electrospinning. So the electric field is going on here. Of course, for safety, we have these yellow bars, which if we pass them by, the electric field will stop to make sure that we don't get electrocuted. And at the same time, while we're electrospinning, we can also 3D print. The advantage of this is that actually we can make scaffold layers, electrospin fibers in between those layers, and continue with another scaffold layer, which gets us actually a 3D structure which has pore size from the 3D printed materials, but at the same time also the fibers inside the structure with the functionalities which we need, such as the odor absorbing or indeed the color indication.